To get my dream job, I need work experience. I need to develop professional skills, also coaching and mentoring, some certifications and CV rewrite too. Internship opportunities would help me greatly.
Join Momentum. Everything you're looking for in one place. Licensed work tools, personalized career roadmap, work shadowing, weekly coaching calls, practical self-paced trainings, verifiable work reference, career workshops, mock interviews, CV rebranding, and LinkedIn profile optimization. This is the real deal. Why worry about shopping for your career needs when you can get everything and more in one place? Join Momentum is a career acceleration program that focuses on practical training and certifications, work shadowing and experience, coaching and mentoring, and personalized career roadmap. For more details and how to start, call +442 045 380 208 or book a discovery call with us on our website www.joinmomentum.co.uk. Follow us on Instagram at join_momentum UK.
Hello, my name is Victor Shonde. I'm the founder of Join Momentum. Join Momentum is a skills development and digital agency. Our focus is on developing and empowering individuals and partnering with businesses to scale. The Join Momentum Career Accelerator program is a 6 months work experience program designed for career transitioners, job seekers, adult learners, graduates, or anyone looking to launch or transition to a career in digital technology. The 6 months program provides and focuses on digital work experience, confidence building, portfolio development, and of course, there are other things like CV branding, LinkedIn optimization that comes as part of the program. The reason why the Career Accelerator program is quite impactful is because anyone that joins the program essentially is applying to work with our team members within the organization at Join Momentum. You work with our designers, our developers, our researchers, our testers, our BAs, including myself, from a product development perspective. So what you're getting is deep experience and knowledge beyond certifications or training or whatever it is that people get. The exchange program has proven to be transformative for people who have come on the program because within the space of 3 months, we expect you to be interview ready, job ready, and we'll support you with one-on-one coaching, mock interviews. We have a huge portal called the Career Transformation Hub with so much resources and information to help you to, when you land the job, to make sure that you're not just getting a job, but you are able to thrive and excel in the job. On skills development, we have 3 offerings: the Career Accelerator program, the bootcamp, and we have self-paced training. Self-paced training allow anyone to log into our website, buy a course, take a training, and get the value from it. Our bootcamps are self-paced inclusive. However, we have instructor-led live training classes with expert coaches from all around the world. Our coaches work with global brands and they have deep expertise and experience in their areas of expertise or discipline. Our bootcamp lasts between 4 to 6 weeks to 8 weeks, depending on the discipline. So if you're looking at transitioning to become a business analyst, user researcher, Scrum Master, an agile coach, a cybersecurity expert, data analyst, and so on and so forth, why don't you check our website and see one of our boot camps upcoming. So, are you willing to launch a career in technology, but you don't have confidence, you have no experience, you're not quite sure about your transferable skills, you have no maybe background training, or even if you have certification, you're not sure what those really translate to in the actual, in the practical sense of things? Or are you willing to increase your earning potential, your earning capacity? I'm talking you want to earn 5, 6, even 7 figures in places like Africa, but you're not sure how to go about it. Why don't you check out our Career Accelerator program, right? And the good thing about it, even if you don't want the Career Accelerator program, if it's maybe too expensive or you're looking at pricing, try one of our boot camps and you can upgrade to the Career Accelerator program from there. I'm looking forward to see you there.
Today we want to talk about the Internet of Things, software development. I know we've had this talk in previous sessions before now. I think one of the classes we had, we spoke about the application of Internet of Things. But today we want to go a little bit deeper, not today, into how to develop software for Internet of Things, more like a starter guide to developing Internet of Things. I will try as much as possible to also recap on some of the things we've mentioned in past about what Internet of Things is all about, and how it affects our lives as a people. So now, what is the Internet of Things? When we say Internet of Things, what are we talking about? We've seen software development, we've seen applications, we've used WhatsApp, we've used different kinds of applications. But when we talk about Internet of Things, we're talking about software development that affects devices, basically. As the explanation here says, it says it's an acronym for, IoT is an acronym for Internet of Things, which is a term that refers to the connection of objects to each other and to humans through the internet. I'm very sure at some point you must have heard of instances where people can control the lightings of their houses from a remote location. Or you probably put on your pumping machine and you are not in the house. So these are very, very good examples of Internet of Things. Or you have a video, you have a camera in the house that you can control or you talk to. From your phone, you can control things in your home. So these are very, very good examples of Internet of Things. But these are basic. There are lots and lots of very good examples and that affects lives in a very, very positive way. Examples abound all across the world where we see the use of Internet of Things affecting lives positively. Okay, so I'm going to look at some of the examples or some of the ways that this has happened. So when we talk about application of IoT, we're talking about connection between machines, humans, then data. It's all about data, actually, data gathering. Okay, so which means that IoT simplifies, improves, and automates processes, basically. And how does it do that? It does that by making use of what we call sensors, coupled with connectivity and artificial intelligence. Okay, so this has the potential of, making several systems more efficient, cutting costs, and also, in cases where we've not seen possible in previous times. So we're going to look at some of the areas of life where Internet of Things have been implemented and making a lot of way. Okay, so if we look at, for instance, enterprise solutions, we talk about cybersecurity, customer analytics, IT assets, service management, and all of that. So you will see that in the area of enterprise, when we talk about enterprise solutions, you will find out that big organizations use enterprise solutions to actually make their services more effective, basically. They optimize operations, they monitor operations, gather data. You understand? So all of these things makes it easier for bigger organizations to improve service, to generate more finances, to make more sales, improve customer relationship, then acquisition of supply chain. then human capital, like payroll, for instance. So, for instance, in the cases of you monitoring operations or gathering data, we usually use IoT devices and sensors to make what we call real-time measurements on, maybe steps of manufacturing processes, for instance, or to track patients, and to track patients' well-being, basically. You understand? Like, for instance, some hospitals use IoT, like some devices, they can plug in a device, maybe to, we've had what we call pacemakers, especially in patients that have heart issues. So with pacemakers, you can actually remotely monitor certain patients, especially when they start having, if they have an issue with their heart and all of that. And it is quick, it makes it quick, makes it easy for you to quickly respond to such cases. So, we have issues like that. So companies make use of a lot of devices, IoT devices, to ensure that their services are more effective, and they can, they can assure better customer satisfaction in most cases. So that is one case, enterprise solutions, basically. Another one is smarter homes. We've had cases of, you entering your house and you can speak to a device to say, change the color of my wall, or put on the TV, or you can do a lot of things. You understand? I've had cases of smart homes that change colors based on your emotion. Okay, if you are sad, it can change the color to an ambience mode that makes it easier for you to maybe recover quickly from your sadness. If you are happy, it changes the color based on your mood. We've had instances like that. Energy consumption can be managed. Security can be managed. We have, I'm giving examples here now where you can actually have cameras in your home and you can control, maybe even speak to people. I think that there is a common case of an intruder that came into a house and the owner of the house was seeing him, and right there and then he shouted and out of the speaker started talking to the intruder. The intruder had to take off, cases like that. You can manage energy consumption, switch off your light remotely, or, there's times that you probably, back here in Nigeria, we usually do that a lot. You forget to put off your light or something like that. Maybe in the morning, there is no power and you've gone out, so then the power comes back. You can easily put an Internet of Things, that enables you to monitor power consumption, so that remotely you can easily just switch off that power. Or you forgot to put up the pumping machine, for instance, you can switch it off remotely and stuff like that. So that's another example. Then in agriculture, a lot has gone into agriculture, making use of Internet of Things for agricultural purposes. For instance, there are agricultural drones now that gives you the capability of being able to monitor maybe animals across a wide area of field. Aerial drones can help you assess crop health, monitor crops, maybe even spray chemicals and do field analysis and things like that. In agriculture, there are cases of data analytics, smart greenhouse. Okay, with smart greenhouse, you can, for example, monitor the wind or the climate and know when to plant certain crops and stuff like that. So you have sensors that collect and transmit real-time data. Okay, so which can help you to monitor your greenhouse, and you are almost 100% generate or create crops that will withstand any form of natural changes, basically. Okay, so things like that. Smart irrigation, smart greenhouse, prediction farming, all of that. So based on, you can put drones, out there that can help you predict the weather or predict climates, and you can know when to plant certain crops and when not to. Okay. Then we have other examples: smart cities, traffic management, pollution monitoring, resource management, parking solutions, infrastructure management, disaster management, all of that. So with IoT, all of these things I don't want to go too much into details in all of this. Healthcare, I've given examples just now. Telemedicine, we've had cases of Indian doctors right there from India performing a surgery on someone that is here, with two doctors talking via, remotely, and stuffs have been done, or even robotics, and innovations like this are made possible there because of IoT. Then power grids, system alerts, abnormality identifications, energy consumption monitoring, and so on and so forth. Then you have device integration. So now, talking about device integration, all of these things we're talking about require some form of connectivity between smart devices, cloud storage somewhere, then human interaction, basically. So now, when we talk about smart devices, we have to look at different device integrations. So, which will include connecting your mobile phones, TV, smartwatches, and laptops, and sensors, okay, such as accelerometers, gyroscopes, and so on and so forth. Some of our mobile phones actually have sensors. It's those sensors that makes it easier for you to be able to do maybe things like geolocation and so on and so forth. IoT infrastructures and devices can also communicate efficiently, to make devices operational for business and consumer use cases. So at this point, you now have to start talking about software engineering that comes into play when you now want to build some of these devices. So now, when we talk about that, when we talk about IoT software engineering, basically what it does is to deal with data collected via sensors and process it to make sense for real-world application, okay, with intuitive UI and visual representation. So basically, simply put, the way IoT works is just basically sensors that are connected to smart devices. Those sensors have been primed up to collect data in different forms. If it's maybe a temperature gauge, for instance, can be built to collect temperature data. A pressure sensor can actually, like for instance, in your cars, that sometimes your cars are able to determine whether there is an occupant in the car or not. When your door is not locked, you can see there's an indicator, that shows. So those ones are even physical devices with sensors. But when you now combine interconnectivity to it, you combine the internet and connect it to the cloud, then you're now talking about Internet of Things. It's becoming more intuitive when it comes to such cases. Okay, so now the software engineering that is involved in IoT is what we really, really want to talk about. And I will try as much as possible to cover that in a very few minutes. Okay, so now what are the types of IoT softwares that we deal with? Okay, now there are two basic types or two major types of IoT softwares. The first type is the enterprise or industrial IoTs. We see that in beacons, RFID tags, sensors, and etc. Mostly in defense. So you see a lot of enterprise or industrial IoTs, being made use of in these instances. Then we also talk about consumer IoT. We're talking about wearables, your smartwatch, your phones, healthcare devices, connected cars. We've seen driverless cars. That's a very, very good example of IoT. We've seen cases, we've seen murder cases resolved because maybe the person that was murdered was wearing a wearable phone, a device, a wearable, a watch that is IoT connected. And they could actually have seen where the person has moved from different locations, maybe before the person was killed and stuff like that. So, so consumer IoT is another type of IoT software development. Then smart homes, basically. So I've given examples earlier. So how do we create IoT softwares? I'm going to be very brief. I won't go too technical. So the whole essence of this is just to sensitize us. And if you don't have interest before, this is more like trying to creating that interest. Like, okay, you can actually develop stuff. You can actually develop IoT applications. It is not that difficult. Of course, you have to start from somewhere. Okay, so how do we create IoT software? Now, We're going to look at some of the steps. So now, the first three components are required for developing your IoT software solutions. The first one is the development platform. The next one is the operating system. And the last one is the programming language you want to use. Now, when we say development platform, we're talking about platforms that are already existing and that has been optimized to allow you create such applications. Okay, so we're going to talk about some of these platforms. I'm not going to go too much into them. We have IBM Watson. We already know what IBM is. Microsoft Azure, AWS. Now, these are the key players in IoT production. So what they do is to provide you with platforms on which you can develop your application. So many of these IoT app development companies offer platforms such as ThinkWorks, Nubo, Bug Labs, Zively, and other IoT solutions. The Raspberry Pi is the most popular. You must have heard about it, Raspberry Pi. Okay, so these are platforms that you can build on top. Then Android things is, these are very, very popular platforms. So especially this Raspberry Pi is very, very popular. They have Raspberry devices that you can purchase from the market and build. It's a physical device. You can now start building on top of it and write your code to do, maybe even connect to, you can do basic things like write an application that can connect to Bluetooth, computers Bluetooth. Write an application that probably can control maybe lighting and stuff like that via Bluetooth or via your Wi-Fi. These are basic projects that students usually do. Okay, so then we also talk about different operating systems. Now, when we talk about operating systems, I'm very sure what first comes to your mind is your Windows operating system, your Windows 10, Windows 11, your Mac OS, your Linux operating system. Of course, yes. But for you to be able to write applications that control devices, now the devices are limited in terms of resources. So this makes it important that the kind of operating system that these devices will carry will be embedded in the same. If you look at your computers, your laptops, your systems in the office and all of that, operating systems run on them. But imagine you being able to carry a device that could probably even look like a phone. And that device has its own operating system. Your phone has its own operating system, Android operating system. Now, the same thing. You can develop any device whatsoever. It could be maybe a Bluetooth device. It could be anything. They must have an embedded operating system. So it must be very small. And the reason why is because the devices are limited in terms of computing, what they can do. Of course, there's a lot of technical breakthrough in that regards, actually, because now we are combining cloud, So what it means is that those devices cannot handle large amount of data at any point in time. But with connectivity to cloud, you can store data in the cloud and connect the device to your cloud and pick data and make use of it as you need. So IoT devices need to communicate with cloud services and other IoT devices over a global network and can do so within tight parameters of limited amounts of memory and processing power. So these are some of the operating systems that have been built to operate on these tight parameters. Contiki is one of them, FreeRTOS, Embed OS, MicroPython, Embedded Linux, Raspbian, and Windows 10 IoT. So these are the very popular ones, especially the Raspbian, the Embedded Linux and Windows. They are very, very, then the Embed OS, they are all very popular operating systems. So these are the things, this is the second thing you need to consider when you want to develop an IoT application. Then the next thing is the programming language. This is usually where you start from, actually. Okay, you have to pick the right programming language that is crucial for developing your IoT application. Okay, so with limited resources, the code needs to be short and easy to compile. Okay, so these are some of the programming languages that are used to develop IoT applications. C, C++, Java, Python. These are languages we are familiar with, especially Python and Java. Okay, so Python, most importantly, is, a very, very powerful language, and Java too. Java started long ago before Python even came into to the scene. Okay, so there is virtually any device nowadays that you can see that does not have the Java programming language on it. Even your TV, all of them probably have a Java programming language used to write some of the, how these devices work. Okay, so these are the languages. So at least you must be able to learn one of this to be able to write an IoT application. Then, what is the architecture like? It's very important to understand what the architecture, how it works. How is architecture? Basically, we are simply talking about how does it work from end to end. So, for instance, if I tell you, let's say, how does your maybe WhatsApp work, for instance. So basically, we say it's a multi-tier architecture. Multi-tier, and when we say multi-tier, it's just English. But basically, what we are saying is that from your device, there is an application, which is the application you are seeing, the client side. When you type something and you say post, now that client side sends the information to a server somewhere. There's a server that has the server-side application to process the information you've sent. That is this next. That's the next side to it. Then that server can now say, oh, maybe the instruction that has been put there is that, okay, once this information is sent, oh, please send an email to the person that sends it or to whoever is going to receive it. Okay, so that server now sends this to a mail server. Now, how many points is that? That is from your front end to the server, that is 2, to the mail server, that is 3. Now, from there, it can actually save a file, that is 4. That's what they mean by multi-tier application. So that's what we mean by architecture. There is a design in place to ensure that once you send a message from one point to the other, there are devices in between that handles those information as they move from one point to the other. That is what architecture means. Okay, so the IoT system too has its own architecture. And let's quickly have a look at that. Now, an IoT-based system comprises 4 stages of architecture. Number 1 is the sensors and actuators. Okay, what do we mean by sensors and actuators? I've explained them. Sensors are just small devices, allow me to use the word listening devices that helps you to gather data that you would normally not be able to gather by yourself. For instance, if you want to measure temperature, you use a thermometer. Now, they've built sensors that can easily measure temperature and send the information back to whoever is requesting for it. Of course, if you take the hospital, for instance, if you get to the hospital and they want to take your temperature, they will take the thermometer and put it maybe in your armpit or in your mouth. Now, who is requesting for that data? It is the nurse. The nurse takes it out and checks, okay, the temperature is 32. The nurse writes it down somewhere. Now, that process of measuring the data, of writing it down, is, in this case now, is automated. So what happens is the sensor reads the data in its raw format and sends it to a storage location somewhere where it is stored. Then developers have now written programs that will pick that data and process the data and use it to do certain things. Maybe to show you, it can be presented in a UI format to say, oh, temperature is high, 35 degrees Celsius. You now see a UI, a user graphics. So the code has been written in such a way to say, hey, if the temperature is greater than so amount of value, display a red color. If it is this value, display a green color. It is as simple as that. Okay, so data preprocessing, the systems, the cloud. So all of these things work together to ensure that your IT-based system works as they ought to. Okay, so in conclusion, the IoT market is growing rapidly and expected to reach a capital of $561 billion by the end of 2022, which we just went past. That is according to Markets and Markets Research Global Forecast. With the growth of the IoT-based environment, there will be a rise in the demand for IoT-oriented software engineering. So like I said earlier, the essence of all of this talk is to pick our interest, in a little bit of software engineering. In fact, we usually have a look at it and say, hey, it's like when Tolu was introducing me now, that it's not, that it's not made for everybody, But the truth is that, yes, the deep end of it might not be meant for everybody, but the truth is that there are some little things, what I choose to call low-hanging fruits, let me use that word, or around software engineering that we can easily pick and pick interest. You don't need to know everything. You can just know one thing. Like, for instance, Python is a very simple programming language. Very, very simple. Anybody can learn it. Okay. So imagine you know Python. You've been able to learn Python. Now, this IoT we are talking about is just basically, there are devices that have been created for you. So like the Raspberry Pi is like an electrical device. Some of us that are inquisitive, I'm very sure at some point we must have opened up when we were young. You've opened up your wristwatch, you've opened up your radio and stuff like that. It's just the way, that's just the way it is. But in this case now, they've now simplified it in such a way that all you need to focus on is ensuring that you connect this device to the other and connect it in the right way that you're supposed to. They are logical, and write your Python code, then execute it. So that's why you see a lot of children. If you go into this IoT now, you see children in it. It's being taught in schools, it's being taught. The reason is that, especially Google has made it so simple that you can easily, in your home, put materials together and start doing something very simple, like connecting devices to your Bluetooth or to your Wi-Fi, for instance, or even writing something as simple as creating a small motor car toy that you can use a remote control to control. You can do it in the privacy of your home without anybody asking you questions. So at the end of it all, I want us to remember that there is a lot, to be gained from Internet of Things and in software engineering in general. So thank you very much for having me. Tolu, back to you.
Amazing.